Tonight's homework is a 2-day assignment, which does not mean start it tomorrow and do 2 days of homework in one day. It just means we're not quite, it's gonna be an uncomfortable bell ring. We're not gonna quite finish everything, but you can do the majority of the homework by today. But again, it's a long assignment, so start some of it. And the title of this, it says, hey, let's use the first derivative test to blah, blah, blah. You don't know what the first derivative test is, but what do you think you need to do? Find the first derivative. By doing power rule. And then to find extrema, I need to identify maxes and mins. So doing that, do the first derivative and find critical points. Critical points are where it's undefined. Where is it undefined?
Nowhere.
Okay, where is it 0?
At 3, -3.
3 and -3. Okay, and last week we did the extrema thing over some fixed interval, and we said put the endpoints on there and then all the critical points and find the values. I don't have any endpoints on this one. It's kind of like negative infinity to infinity. So I am not going to have any absolute extrema. I know what this graph looks like. It's a cubic, lead coefficient is positive. So that first one is going to be a local maximum. The second one's going to be a local minimum, but let's use the calculus to find that. I'm going to put this on a number line for the first derivative, put all my critical points on there, and then I'm going to pick numbers to test. And then am I testing the function or the derivative?
The derivative.
Derivative. Sophia, picking a number -100. Is it going to be positive or negative?
It's going to be negative. No.
So 100, -100 squared became really big and positive, and then subtracting 27 from that would be positive. Putting in positive 100 also. Putting in 0, Constantine putting in 0, derivative positive or negative?
Negative.
Negative. So that means the slope was positive till right here, and then it started being negative. Till right there, and then it started being positive again. Reaffirms, okay? The slope went from positive to negative, stopped going up and started coming down. That's going to be a maximum. Probably a local, but it's some kind of maximum. And then the slope was going down, then to up. That's a min. Good? Make sense? Yeah? Okay, so today we will try to get through understanding what F prime and F double prime mean, and visually what information that gives. So there's all that. So just looking at the picture, if I did the first derivative was positive and 0 right there. So that is a critical point. Is that critical point a max or a min? It's not. It's neither. It's neither. It's whichever. It's not one of those. So, and it's because the first derivative sign didn't change. It's still a critical point at C1, but it's not a max or a min. At C2, the first derivative was positive, then went negative. When the sign changes that way, it's going to be a max. Happens to be an absolute max, or nope, it's not. I would have to do more checking to figure out if it's absolute or just local. Here, first derivative went from negative to positive, so it's a min. Positive to negative, so it's a max. Negative to negative, not a max or a min. So we're gonna put in words like the justification you're gonna have to put on your next quiz on this. So here's our justification. So Felipe, if all I tell you It's the first derivative change from positive to negative at C. What do you know happens at C?
It goes from positive to negative.
Okay, so if I was to draw f prime going from positive to negative, what would that look like?
How the slope changes.
Slope changes from, like, okay, so he went like this. So it went from going up to going down. At x equals c, where it changes sign, what is that spot going to be?
0. Or at the slope is 0.
Well, 0 are undefined, but what am I getting at?
It's a max, it could be local or absolute.
So when the sign changes from being positive to being negative, you know that there's going to be a maximum. Why? Because, like, that's what it means. You stopped going up and you started going down. It's going to be a maximum. So this is the kind of thing you're going to have to write as justification. Ben, why is it a maximum? Well, I did the number line and the first derivative changed from positive to negative. There's going to be some kind of maximum there. Alex, what about the other way? The first, it's a minimum. First derivative changes from negative to positive. At that x value, there will be a minimum. Does it mean the minimum is C? No, it's just at x equals C. Evelyn, what if the sign doesn't change?
It's a critical point, but it's not a max or a min.
It's a critical point, but it's not a max or a min. Okay. Now here's another question. Here's A, here's B. A is my left endpoint. Alana, if the first derivative from the start is less than 0 at A, what do we know about A?
It's decreasing.
So the slope is going down, so the line is decreasing. So is A going to be a local max or a min? It's going to be a max. So I don't want you guys to like memorize this or anything. I want you to be able to draw it. Left endpoint, and she's looking up at the ceiling. It's going down from there, which means it was a high point. Draw it for yourself if you need to. And then the opposite of that, if from the left endpoint everything was going up from there, it's going to be a minimum. Okay. Paulo, other side, at B. What if the first derivative you pick? Is it greater than or less than?
Less.
Coming into B, what does that mean? So as we come in towards B, it had a negative slope. It'll be a minimum. Okay? Get how to reason that? Like, I have concept dyslexia. If I tried to memorize this, I guarantee you I'd get it wrong. And then the other way, like, just by knowing what the slope is doing at the beginning and towards the end, you can determine are those endpoints highs or lows. You still need to do the table to find out if they're absolute or not, but you can still say there's a minimum or a maximum based on what the slope is doing. All right. Concavity, you guys talked about it in pre-cal last year, or IBSL or AB Calc. What does concavity mean? Really?
It's like if the second derivative is greater than 0, then it's concave up. If it's less than 0, then it's concave down.
Okay, they don't know that yet. So it's curviness. How curvy is this? It's how is the first derivative changing? And she just said, like, if the first derivative, the slope here is being less and less positive, more and more negative, it's decreasing the whole time. This is concave down. And we gave you a rhyme in pre-cal last year, concave down makes a brown. Pre-cal was like, rainbow. Like, I was looking for a rhyme. And then concave up, they were, makes us smile. Oh, well, makes a cup, holds water. So the U in cup, the N in frown, however you need, yeah.
Couldn't it still be concave up even if it's negative, if it's something like a negative square root graph where it's negative but it's fractional?
Okay, so here's the thing. Here's concave up. All pieces that are concave up. I can have a function that's concave up that has a negative slope or positive slope, but the whole time that curviness is up. If it's frowny face, it can be concave down but an increasing slope, and concave down and a decreasing slope. But if it's some part of the N of down or the U of up, it's going to be that concavity. Yeah.
The way I want to do the pre-cup is like if you could draw a line from like one point on the graph to another point that's above the actual graph, then it's concave up, and then if it's below the graph, then it's concave down.
Yeah.
Is that like kind of accurate?
Yeah.
Yeah.
So you're saying,
Yeah, like that, but then if on a parabola, if you pick 2 points, the line would be above the function.
okay, so this one's concave, this is a parabola. You're
Well,
saying,
that's a negative one, so that's concave down, because the line is below it.
okay, if that's how you see it.
That's-
That will confuse you with something else we're gonna do today, though.
Okay.
There's some lot of similarities, but the opposite conclusion.
Okay.
So, but what you said is not wrong. Okay, they say this kind of thing, oh, it's concave up when y prime is increased. No, we don't care. We're gonna say it this way. Something's concave up, Lily said this a moment ago, it's concave up if the second derivative is positive. This is a y double prime, and it's concave down if y double prime is less than 0. And AP will ask, consider these softball questions. They'll be like, hey, how do you know it's concave up? The second derivative is positive there. So you need to be able to justify things.
And when it's equal to 0, it's a straight line, so it doesn't have concavity.
It could be in transition. So, oops. So, y equals 1. First derivative 0, second derivative 0, no concavity, it's flat like a board. This one, first derivative is 1, second derivative is 0, no concavity, it's a flat straight line. Y equals x squared, critical point at 0, double derivative is 2, double derivative is positive, it should be concave up the whole time. I know what it looks like. Swoop, concave up all the time, happy face, makes a cup, whatever. First derivative, second derivative at 0. Concavity changes. It went from being concave down to concave up. First derivative and second derivative are 0 there. Horizontal tangent, concavity changed.
Okay.
So there's, careful. You might need to know about things on the other side. Okay, point of inflection. Sounds a lot like a critical point. I don't want to give a definition that's above it because I feel like it's wrong, even though your textbook says so. Inflection points are where the second derivative is 0 or undefined. And now there's a kicker. And it needs to change sign. If you guys haven't written anything yet today, write that down. What makes an inflection point an inflection point? Where the second derivative is 0 or undefined. You guys always skip that one. And the second derivative needs to change sign. There's an extra condition. Similar to critical point, but there's an extra piece. So, in this equation, find the critical points, find the inflection points, and give justification. Just in case we need to write things down. Monica, first derivative? Okay, multiply by the power, lower the power. -2 over x minus 2 squared. So critical points where this is 0 or undefined, so x equals 2. Double derivative, multiply by the power, lower the power. +4 over x minus 2 cubed. And I don't know if it's an inflection point, I need to check if it changes sign. And I'm already making mistakes here. But checking the second derivative, at 0, its concavity is negative. At 5, its concavity is positive. But x equals 2 is not an inflection point. And as a matter of fact, x equals 2 is not a critical point. Why?
You didn't do chain rule?
No, I did the derivative right. Alana?
It's not continuous.
Is 2 in the domain at all? Yes, concavity changes at x equals 2, But 2 wasn't in the domain in the first place. AP will do this to you, and this is the second time I've shown it this. They will be mean. They'll be like, I got you, tricked you, it changes, but it wasn't on the in the problem itself. So, just making it so you don't fall for it when they put it on a test. Okay, so, I think it was a week ago that step 1 was identify the domain of the function first. I deliberately didn't do that here. Again, but check. And you're allowed to rely on pre-cal and algebra 2 to be like, I know what that looks like. You still have to, if they asked you where is it concave up, okay, this function is concave up, negative infinity, round bracket, to 2, round bracket. And it's concave down there, concave up to infinity. Like, why? Because the second derivative was positive. Fun derivative and second derivative, because I'm asking for inflections. E to the stuff is E to the stuff. And then there's some chain rule. Derivative of e to the stuff is e to the stuff times derivative of stuff. So 2e to the negative x squared times negative 2x.
Wait. Negative x squared.
Double derivative.
Wait.
What? What now?
Is it? Why is it? It's
Yep.
not to the negative.
Yep. Copying things wrong. Okay. Ugh. Product rule. First times the derivative of the second. Derivative of e to the negative x squared is e to the negative x squared times the derivative of the exponent plus second times the derivative of the first. Grossness, if I factor out negative 4 e to the negative x squared, I'm left with negative 2x and 1.
Question.
Yeah.
Is it negative 4x? And the second? Minus negative 4x?
Yeah, I'm doing things wrong.
Like negative 4x times, like for the first time derivative of the
This
second.
negative 4 is a 4x.
Yeah.
Because it was the derivative of first times the derivative of the second. Okay. So where's it undefined? Nowhere. Where is this first term? 0? It isn't. Where is the second one? 0? Plus or minus square root of a half. And it's asking me for points of inflection. So the reason I did the double derivative, points of inflection are where the second derivative is 0 or undefined, and it needs to change sign. So I need to check. I'm labeling the number line because now I got the function, I got the first derivative and second derivative. So you'll have checking like negative 8 million. Is the second derivative positive or negative? I should look over here. So negative 8 million, this is gonna be negative, that's gonna be negative, I think it's positive.
It's positive for e to the negative x squared. Wait,
It wouldn't possibly
I think, because for the second derivative, I got 4e to the negative x squared times 2 x squared plus 1. I'm not sure what it's with.
I factored out a negative 4, which made it weird.
I factored out a negative 4e to, yeah, I did. I factored out 4.
Okay,
Oh, wait,
positive
you
4.
factored negative. Yeah, I factored out just for the combination. Because
So I ended up getting a negative times a negative when I plugged in negative 100. Because the e thing here, that part's always going to be positive. So it's negative 4 times negative something. It ends up being positive. Plugging in 0, I get negative times positive, and then plugging in positive 100. So these guys are points of inflection. Why? Okay. 0 there and a change sign.
So that's the justification.
That's the justification.
And we'd have to write that all out for,
Pretty much.
okay.
You can use B/C for because. And you could say equals 0 instead of the words is 0. Which is fine, but I will try to write out the word 0 so it doesn't look like a O. Okay. Right, now here's where the bell's gonna ring soon enough. Not quite yet. So just, what do we know now? Well, if the first derivative is positive, the curve is rising. Can the curve do this if first derivative is positive? No, like, it means you're forever going up. So there's restrictions when I tell you it's positive, Alex. You're like, okay, it's gonna have to fit a particular kind of thing. If the curve is falling, y prime is negative. It's gotta do that, it can't do any wiggles. And if y prime is 0, there's a possible maximum, or maybe it's an inflection point. Maybe it didn't max out. Or maybe those tangent lines are real and it's gonna make a max or min. Concavity, it's gonna make concave up or concave down, it's gonna look something like that. And if the double derivative is 0, as Daniel said before, okay, well maybe it's boring and it's just a horizontal line and it's just totally 0 and it doesn't do anything fun. Or maybe the double derivative is 0 and it did something like that. Or, let's assume that was a horizontal tangent. Or maybe it does something like this. Here's the question. Yoav, what do you think? If I tell you the first derivative is positive, or first derivative is 0, and the second derivative is less than 0. What do I know is going on?
It's a local maximum.
It's a local maximum. How do you know that?
Because it's a critical point because the first derivative is 0, and then it concave down because the second derivative is less than 0.
So Ben, this is my concern about the way you've got the other thing remembered from pre-cal. He just said, okay, because second derivative is negative, it's concave down. So we've got that little frowny face. Then he said the first derivative was 0, so it's got a horizontal tangent. That horizontal tangent sits on top, so it's going to be a maximum. This is what's called the second derivative test. And there are times that they will give you information, they won't give you the whole function. Okay, Daniel, what if it's the other way around? First,
It would be local minimum.
it would be a local minimum. So first derivative is still 0, but second derivative is positive, so the opposite of what Yoav said. Okay, well now it's concave up, so the tangent line is down below, and it's gonna make a minimum. All right. Then Felipe, what about this?
That's a max.
It's a max, why?
Because F prime is, G prime is 0 and G double prime is negative.
G double prime is negative, and then that tangent line, horizontal tangent line, it's gonna be a max. I don't know if it's absolute or local, but there's gonna be a max. Okay? Cool. Lily, what about that one? Do we know?
I don't think we know. Well, it's not, would it not be either?
So, do we know, or
It might have an inflection point.
it might have,
We
so.
don't know about the sign change.
You don't know about the sign change, so you're not sure. Like, it could be a parabola, or it could be a cubic, or it could just be a horizontal line, you don't know. So not enough information, and it's really, really hard to have the confidence to be like, I don't know, and you can't make me know. They needed to give you more information. All right, I don't wanna do that yet. I wanna look at this. So I wanna tell you how powerful, like, just saying something's differentiable. Constantine, can you draw an example of a differentiable function, just on the board somewhere? And, Ben, can you draw another one? Okay, classic quadratic. Classic cubic, okay. I don't know, draw that one. So are all three of them differentiable? Yeah, okay. Is that differentiable? So immediately, if I tell you it's differentiable, I'm immediately telling you it doesn't do anything super fun. It doesn't break, it doesn't have any pinches or corners, so it's gotta be nice and smooth. So Andy, what if I now say, and y prime also has to be positive?
That means that it has to,
Like, does mine pass the test anymore? This one down here?
no,
No. How about Constantine's?
no, because it's decreasing.
Decreases for some of it. What about Ben's?
Yes.
Yes. So by telling you it's differentiable and the first derivative's positive, I'm not allowed to turn around and have a negative slope anywhere. So it's got to be constantly increasing. Okay, and now this one constantly decreasing. It's got to be a little snaky thing going down. Okay, okay. Evelyn, what if I say it's differentiable and the second derivative is greater than 0? It's got to forever be concave up, so could it do what Ben's function did? Could it do what Constantine's did? Yes. Could it be mine? Can't be mine because mine goes up and down and changes concavity. So it could just be half of the U shape that Constantine drew. Okay? Sophia, what if it's concave down?
Oh, it's like less than 0?
So,
Yeah, it's concave.
and is it allowed to like wiggle in there? No, because the concavities would have changed, right? So by saying it's differentiable and the first derivative is positive is restricting, or it's differentiable and concave up. It can't wiggle wiggle. It's gotta stay concave up that whole interval. What if the double derivative changes sign?
It changes concavity.
Changes concavity, what does that visually look like?
Cubic function?
Cubic function. So it either went from being concave down to concave up, or concave up to concave down. Could it be, how do I draw it that it doesn't mess up? I don't know. But it needs to change concavity and it needs to do it smoothly and not on any kind of jump. Differentiable and y prime changes sign. It's a critical point. What does that mean?
It's max or min.
Yeah, okay, it's more than a critical point. If I tell you it has to change sign, it will be a max or a min. And if you know which way the sign changed, if it went from positive to being negative, it stopped going up and started going down, you'd know it's a max. Or if you knew it changed from negative to positive, you would know it's a min. This one, differentiable in first derivative 0, second derivative is negative. Andy, what do you think? First derivative is 0, second derivative is negative.
That means that it has to be a maximum.
Second derivative is negative, first derivative is positive, or 0, it has to be a maximum. So this information tells you lots and lots of stuff that you can mathematically justify. And by telling you it's differentiable is super restricting. All right, we will do more of this tomorrow.